how to basically take equations and write them as multiplication problems. It's going to look like this as your answer. So this is x plus 3 times x plus 4. So we basically want the parentheses for something that's factored. Factoring almost always leads to something that's in parentheses like this. The only time it doesn't is if something's not factorable. And basically what this is doing is setting it up so that we can solve this equation easier. So when we change it from this to this, we can solve the equation a little bit easier. But realize none of these are equations yet. They're just expressions because there's no equal sign. So we're just kind of rearranging them today and making them look different. Right? And we're only going to talk about this section, not the middle section, but the last one. Because the first and the last are actually pretty easy. The middle one isn't that much more difficult. It just takes more steps. So I'd rather talk about that tomorrow and just do that one on its own. So I'm splitting this lesson up since it's our first remote lesson in a while. It'll be fine, okay? So this first one's going to be super, super easy. You're going to take everything in this parentheses and multiply it over here. We're going to review how to multiply so that over here we can sort of unmultiply and set it up as a multiplication problem. So when we're multiplying, we would take this x times this x and times the 4. X times x is x squared. X times 4 is 4x. Then you would do the same thing, but with the 3, and multiply the 3 to both of these, which would make 3x and 12. And then we'll combine those together. Like that. So in the middle, these two get added together because they're both x's. And that happens every single time when you multiply two things like this. The pattern we've just created is that the two numbers that were in parentheses add up to the number in the middle. So 3 plus 4 is 7 because we added them in the middle right here. So they add up to the middle number because they get added together in the middle. And then the last number is when we multiplied those two numbers. So they multiply to the last number. So basically what we're going to do to undo this and go from here backwards is find the two numbers that multiply to this number and add to this number. And we're just going to follow that pattern all the way through. So your first step is going to be to find two numbers that, and then I'm just going to draw an arrow to say that they're going to follow this pattern right here. And there will only be one answer between two numbers that does both of these things. So there's only one possible answer to this whole thing if you do both of the rules. And then what you do with those two numbers is you're going to write it in what we call factored form with two parentheses that have x's in them. And the two numbers go here and here, kind of like the 3 and the 4 did. It'll be plus if they're positive, but it could also be minus if they're negative, so I'm not going to write pluses right here, because then some of us will assume that they're always positive, and they are not always positive. And it's really not as complicated as that makes it sound. All you're going to do is take the last number, and I'm going to list all the numbers that multiply to 30. You can also ask yourself, using mental math, what multiplies to 30 and adds to 11. However, I like to show you how you can find those numbers in case, because sometimes it's kind of difficult to think of all of the numbers that go into 30. 30 is not so bad, but if you get a higher number like 98, you're going to start getting into some weird numbers. So if you're stuck on what numbers multiply to 30, start with 1. 1 times 30 is 30. then go to 2. 2 times 15, then go to 3, 3 times 10. Then you would go to 4, but 4 doesn't go into 30, so we skip over to 5. 5 times 6 is 30, and then we would go to 6 next, but since 6 is already on our table, that means we're done. These are all of the numbers that possibly go into 30. So that's how you make sure you get all of the possibilities. You do not have to write down all the possibilities for all of the problems, just if you're having trouble finding the two numbers. Then I'm looking down my list and adding together the numbers to see which ones add to 11. And that's why there's only going to be one answer. This is everything that multiplies to 30. We want to pick the two that add to 11, which is going to be 5 and 6. So my two numbers are 5 and 6. So one parentheses is x plus 5, and the other one is x plus 6. It does not matter what order you write them in. And that's it. That's the factored form. Because when I multiply this out, I would get x squared, and then I would get 6x plus 5x. And that's how the 11x would come back. And then at the very end, 5 times 6 would be 30. So you can kind of imagine yourself multiplying it back out if you want to check your answer. You do not have to do that, though. And then on the next one, I chose all 30s for this top half so that we could focus on the signs, because now we're multiplying to negative 30. And when you multiply to a negative, one of your answers has to be a negative. And it doesn't matter which one you do. I just start with the negatives on the left side of my table like this. And then if I get the wrong answer, I just switch it over. So I'm copying the same table. I'm just giving one of the numbers a negative. And it doesn't really matter right now. I'm just guessing. And now I'm going to try and see which one of these adds up to 7. It's also okay if it adds up to negative 7, because that just means I need to flip the negative to the other one. So that's 29, 13, 7. So negative 3 plus 10 is 7, meaning that my two parentheses are x minus 3, because it's negative, and x plus 10. And hopefully this is like kind of coming back to you. This should have been something that you talked about in Algebra 1. But I'm re-explaining it anyway because that was 2 years ago for most of us. I probably talked about it briefly in geometry, but not a whole lot. Sorry. You guys don't really know this because you have a class of 24 people, but my room has motion sensors, and sometimes they just decide to go off if I don't move enough. Okay. This one. We want to multiply to 30 again, but we want to add to negative 13. The only way to multiply to 30 and add to negative 13 is if everything is negative. Because when you multiply two negatives together, it makes a positive. So it's still 30, so I'm picking the same numbers. Kind of did that on purpose. And then I want to figure out which one adds to negative 13. So pay attention to this sign as well, because this means either both of the numbers are positive like this, or both of them are negative. And you have to use the middle term to decide. And then I'm going to look down my list. Negative 31, negative 17. Be careful. A lot of people think it's that one. This one makes negative 13. So negative 3 and negative 10. And just a reminder, we're just changing the way the problem looks. These are the same thing, but this one is going to be easier to solve eventually. And it's going to be easier to work with, and I'll show you why when we get to those sections. We have to learn how to factor before we can use factoring. And then this very last one follows this rule right here. A greatest common factor is a number that goes into all of these. So 2 goes into all of those. And what you're going to do is divide them all by 2, But the 2 can't just go away like it does in an equation because there's no equal sign. So instead, we just put the 2 out here because we still have to be able to multiply and get this back. And if we just get rid of the 2, then that's not going to happen. So we just set it outside, and then we're going to kind of just like forget it's there for a second after we divide these by 2. So 2 divided by 2, negative 26 divided by 2, negative 60 divided by 2. Then, covering up the 2, this problem is just like these. So I'm going to figure out 2 numbers that multiply to negative 30 and add to negative 13. Since it's negative 30, I need one of them to be negative. So I'm going to copy down this exact same thing that I did up there. Okay. And then I'm looking for ones that add to negative 13 in the middle. And the closest I can get right now is that these 2 add to 13. In order to make it negative 13 instead, I make this the positive and this the negative. So if you've guessed the wrong negative, you're going to realize it has the same number, just the opposite sign. And you just switch the negative to the other one. Super easy. So the 2 should be positive, and the 15 should be the negative. And then you leave that 2 out front. So a greatest common factor is a number that you can divide all of these by. And we just put it in the front, and we kind of just forget about it. It has to stay out front, but it doesn't change what we do with the rest of the problem. Okay, that's the first type of factoring. It takes a lot more kind of figuring out which numbers you want. This one is going to do the same thing, but we're going to talk about this one tomorrow. So we're skipping this for a moment. If you want to write Thursday up here so that you remember this is the one we're doing on Thursday, and that's why we skipped it, you can. And then we're going to do this last one. For the last one, there's a really special pattern that makes these the easiest type of factoring ever. But if you don't understand the pattern, then you're never going to remember it. What happens when I multiply these together, just like I did up there, is I'm going to get x squared minus 3x, and then positive 3x, and negative 9. When I go to add together my middle pieces, negative 3 plus 3 is 0, because these are the same number, just opposite signs. So only the x squared and the negative 9 are left. And there are 2 parts to this pattern. And the parts are that the numbers inside the parentheses are opposites. So 3 and negative 3, or it could be 4 and negative 4, but it has to be the same numbers. Just you change the plus to a minus. And in the original problem, the middle pieces, I'm just going to call it the middles, cancel, like that. So all of these only have 2 terms left. That is why they are called binomials, whereas these are called trinomials. A bicycle has 2 wheels, so these have 2 terms. Tricycle has 3 wheels, so these have 3 terms. And I'm going to use those phrases to help you remember which method you're talking about. For the one with 2, we're going to do this method that's super easy, but you have to remember that this is the one you do when there's 2 things. So what we're going to do is square root both terms. And then we're going to set it up as one with a plus and one with a minus. And this is going to make more sense once I do my first problem in a second. If you're like, what is she even talking about? Give it a second, because this is going to be more of just a reminder once you see some of these. So when you do the square root, I'm going to start with this one with a 9. The square root of 9 should be 3. But if you want to know how to do it in a calculator, you hit the second button and then the x squared button, which is on the graphing calculator on your Chromebook. I also don't mind if you Google what is the square root of 9. That's not cheating on the assignment. So this one is 3, and it gets an x, because the square root of x squared is x. It just gets rid of the 2. And then the square root of 49 is 7. So my factors would be 3x plus 7 and 3x minus 7. And that's it. Because when I multiply these together, I'm going to get 3 times 3 is 9x squared. And then I'm going to get negative 21x and 21x. Those are always going to cancel, as long as these are the same thing, just different signs. And then negative 49 at the end. So this is really just following the pattern, but I'm also trying to explain to you why the pattern actually works. And then this one, for instance, there is no number in front, so the square root of x squared is just x. And the square root of 121 is 11. So you would have x plus 11 and x minus 11. Doesn't matter which one goes first, but I like positives, so I usually think of them first. And then the same thing here, the square root of 4 is 2x. The square root of 81 is 9. So we have 2x plus 9 and 2x minus 9. This very last one is a little tricky because there's actually a number you can divide both of them by, but I'm going to save this before I do it. On the assignment, I tell you when there's a greatest common factor. At least on this assignment, I do. In the future, I might not say specifically that there's a greatest common factor, but 4 goes into both of these. So I'm going to put a 4 out here and then just divide. 36 by 4 is 9x squared minus 100 divided by 4 is 25. And I realize some of you know that in your head, and that's fine. Just use a calculator if you're not sure. Nothing wrong with that. Then we do the same thing with just these. We don't really worry about that 4 out there. So this one would be 3x, kind of like it was on this one. And this one would be 5, because 3 times 3 is 9, 5 times 5 is 25. So you have 3x plus 5 and 3x minus 5.